Let's now take a look at the graph of the natural logarithm function and note some properties of the logarithm function. So first of all, the limit as x goes to infinity of natural log of x is infinity, and the limit as x approaches 0 from the positive side of natural log of x is negative infinity. So this first limit, why are these true? Well, the first one, any x value that you pick as it's getting bigger and bigger, there is some natural number n so that 2 to the n is greater than that x value and less than that x value. So in other words, any real number is between 2 powers of 2. Well, the reason I wrote my x as 2 to the n power, or approximately 2 to the n power, is inside exponents factor down. So this will come out in front. Here it is. So now you're looking at the limit as n goes to infinity of n log of 2. So this is a constant times n. So you can take that constant and factor it out of the limit. Right here it is. And then limit of n as n goes to infinity is infinity. So that's why this limit is infinite. And then to get the limit as x approaches 0 from the plus side, we can do a substitution. So let x be 1 over t, then this x will be 1 over t there, and then this x is 1 over t. As your t in the denominator goes to 0, 1 over 0, or 1 over t, that's going to go to infinity here. So this is the limit as t goes to infinity of natural log 1 over t, but 1 over t is the same as t to the negative 1, and inside exponents factor out of logs. So that negative 1 is right here. And then I can factor constants out of a limit. So this is now negative 1 on the outside of limit of log t as t goes to infinity. Oh, that's this log right here. I'm sorry, that limit right there, just with t instead of x. So this is infinity. With the minus sign out in front, that's minus infinity. So with that in mind, if you graph the natural log function, it looks like this. So this is y equals ln of x. And notice as x approaches 0 from the plus side, log graph goes down to minus infinity. As x goes to infinity, this log graph just keeps going up, goes to infinity. So it goes very slowly. Log's a slow-growing function. So some notes here. Notice that the domain of the natural log function is only positive numbers. So this is 0 to infinity. And the range, well, it goes down to minus infinity up to plus infinity. So our range here is negative infinity to infinity. Also, notice that it's an increasing function. So in other words, if you've got a bigger number, it'll have a bigger log. So if we pick a value here, go up and find its log, and then pick a bigger value and go up and find its log, then that log will be bigger. So a bigger x value gives a bigger log. Log is an increasing function. Also, the number e, you're familiar with that number. It's an irrational number. It is defined as the number where the natural log of e is 1. There's only one number because the log function is 1 to 1. It's got an inverse. So it's increasing here, so that tells you that it's 1 to 1, so it's got an inverse. And so the natural log of e is the one number with log of e is 1. So 1 would be about right here on the y-axis. So if I go across to the log function till I hit and come down, that value is e. So the one x value that has a log of 1 is e, and that's how the number e is defined. Also note that the natural log is a continuous function. It's all one connected piece. And it's differentiable. It's got a tangent line at every point, and that tangent line has a slope. And we already know what the derivative of the log function is. It's 1 over x for x values that are greater than 0.